reactions, but the first thing, in order to understand what is a nitration reaction and how is it carried out, what is the basic chemistry behind it, let us understand it. So I think my board is visible to everyone. So let us start with the nitration reaction. So what we call it is aromatic. It is called as aromatic electrophilic substitution. Aromatic electrophilic substitution reaction. Now, all the three words have significance. Aromatic means, obviously, an aromatic moiety is involved. What do you mean by electrophile? What is substitution? So, all these three words have significance. Electrophilic substitution, electrophilic substitution. Substitution means one group is replaced with the other. Electrophilic, what does electrophilic mean? So when we're talking about nitration reaction, I have to generate an electrophilic species. So how is nitration carried out? Obviously it is carried out with nitric acid. Now nitric acid generates an electrophile, an in situ reagent which is deficient of electrons, electrophile which is deficient of electrons. So that is why it is electrophilic in nature. How is nitric acid responsible for nitration? Alone nitric acid cannot generate that electrophilic species. It has to be combined with sulfuric acid. It has to be combined with sulfuric acid that generates an electrophile which is called as nitronium ion, NO2 positive. That NO2 positive attacks the aromatic ring and replaces one group, hydrogen, with NO2. That is the basic overall reaction. So I'll write the overall reaction for you. What is it? You take nitric acid plus sulfuric acid. So you take nitric acid plus sulfuric acid, HNO3 plus H2SO4 will generate nitronium ion NO2 positive plus HSO4 negative plus water. So this nitronium ion actually is the electrophile or the species which carries out the aromatic electrophilic substitution reaction. So you have to generate. Agar nitric acid or sulfuric acid ka reaction to generate NO2 positive is not correct, the nitration reactions will not undergo or will not continue further. So I hope this basic understanding of the generation of nitronium ion is clear to everyone. So let's move ahead with how the reaction is carried out. So the first is to prepare m-dinitrobenzene. The first preparation using this NO2 positive is to prepare m-dinitrobenzene. Now what is m-dinitrobenzene? M-dinitrobenzene is this species. You have nitro group at the first and the third position. So you call it meta position, 1,3 position is meta. So meta-dinitro, because there are two nitro groups, so it is called meta-dinitrobenzene. How is it? The starting material is obviously nitrobenzene. So you start with nitrobenzene, carry out its nitration using nitric acid in the presence of sulfuric acid, and you get meta-dinitrobenzene. You start with nitrobenzene, carry out the nitration in the presence of sulfuric acid, you get meta-dinitrobenzene. My first question is, why nitro group is attaching at the third position, at the meta position, not at the second or the fourth position? My first question to the students is, why the nitro group, the second nitro group, goes at the third position, not at the second or the fourth position? Obviously, the role of already present nitro group is there. Obviously, the nitro group which is present already on the aromatic group plays an important part, that is directing the second nitro group to go to the second position or the fourth position, or ortho and para position. But actually it is not going to the ortho and para, but going to the meta position. That means the nitro group already present is a meta director. It is directing the second nitro group to go to the meta position. So that is why you are getting m-dinitrobenzene as a product when you carry out the nitration of nitrobenzene. I hope I am clear with the reaction that you have to carry out. Now, what do? You prepare nitric acid and sulfuric acid fuming mixture. You take nitric acid in some amount and sulfuric acid in some amount, mix them for some time, and you prepare the nitrating mixture. So that is called as a nitrating mixture. Alone nitric acid is not called as the nitrating mixture, but nitric acid combined with sulfuric acid is called as the nitrating mixture. So once you take the nitrating mixture, prepare it in situ, मतलब जब आपने लैब में रिएक्शन करना है तभी आपने उसको प्रिपेयर करना है. You cannot leave it. You cannot prepare it before or one day prior and do the reaction the next day. No, you have to prepare there and then, add it to your substrate and carry out the reaction. That is why it is called as in situ reagent. So what you do is you take nitrobenzene, which is your reagent, which is your starting material, which is your reactant. So you take nitrobenzene 6 ml, you take nitric acid 7 ml and sulfuric acid 10 ml. So these are the ratios which have to be added once you carry out the reaction. So how do you carry out the reaction? You take, first of all, you have to prepare the nitrating mixture. You first of all take 7 ml of nitric acid, add it to your flask and add drop by drop sulfuric acid to the same flask, but you have to add it very drop by, keep cooling the mixture, because then it can be that the reaction can be vigorous. You have to keep on cooling the contents so that your nitrating mixture is ready for use. So you take, initially you take what? You take nitric acid, add sulfuric acid to it, adding 1 ml. And after the nitrating mixture is ready for 5-7 minutes, keep it, and then you start adding your substrate or your reactant, which is the nitrobenzene. The nitrobenzene is added, and once the entire contents of the reactant are added, you have to add it in installment. Add 1 ml, wait for 5 minutes, shake the contents well. Add another 1 ml. Wait for 5 minutes, shake the contents. So within 15 to 20 minutes, you have to carry out the entire addition of 6 ml of nitrobenzene. So once that happens, you have to wait for the contents, you have to wait so that, because why is it so important to add the contents in installments is because the nitration requires time. What are we doing? Let us write the reaction. So what am I doing is, I'm writing the reaction, there is hydrogen present. I am replacing a smaller atom with a bigger one. So you can see the replacement. Substitution ka matlab hai, one group is getting replaced with the other. I'm replacing the hydrogen with the nitro group. So once I'm replacing hydrogen with a nitro group, so a smaller group is replaced with a bigger group, will require time, will require some time to be added. So what will happen if you do keep on adding it in a hurry, there will be a large amount of unreacted reactant that will remain at the end of the reaction. You do not want that the unreacted part, that is the unreacted nitrobenzene should be present. You only want that the m-dinitrobenzene, which is your product, should be formed in the reaction. For that, you have to keep on adding it in installment. First, make the nitrating mixture, wait for 5-7 minutes, then add in installments your reactant, which is your nitrobenzene. And finally, once you have added it, you can actually purify your m-dinitrobenzene as a product.